Okay guys, welcome back to Bookmasters Academy. For today, we'll continue with our series on dimension analysis, where we'll use dimension analysis to solve another very important problem on deriving the relationship between physical quantities. Be sure to stick around. Don't forget to subscribe to our channel and share these videos to those that are in exam classes, those in science, those that love science, all those that need these videos. Make sure to share it to them. Okay, so at the end of this video, we'll be dropping our Bookmasters quiz. More information on this will be provided towards the end of the video. So thank you. Without further waste of time, let's go straight to business. Consider a small bulb of radius r. So we want to get the relationship as usual. The relationship between quantities. So this time around, the radius is the quantity. So radius of what? A small bulb through a viscous liquid of viscosity, something that looks like N. So let's just write this down. So okay, we don't even need to bother ourselves. I'm seeing the I can see the relationship. Wow, relationship is already here. So we'll just pluck it out. So let's just identify them. So that's basically what we'll be doing here. So you can see it can be this easy to derive. Let me just put that N. You have your y raised to power y, and I think I labeled this so much. I think that's y. K is dimensionless constant, and x, y are determined by. Okay, that's v. I shaded too much. That's v. Good. So this is our relationship. Let's continue. So viscosity is there. Viscosity is that thing that looks like N, and velocity. So we're trying to get the relationship or the exact relation between force. Which force exactly? Derive from relation. Okay, between viscous force with three quantities here. So we have radius, we have viscosity, and velocity. So let's see what we can do right now. At this point, at this stage, I think this has already skipped a lot of process for us. We'll just try to convert everything into dimension. That should be the next step to get the dimension of everything. I believe you'll be scared by now, but let's just get it and get it right. For force, we already derived the dimension. It's in the part 1 of this series, and you can check it up. Link is on the screen. However, for this, let's just drop something. For force, our dimension, so we'll not start deriving it again. Dimension is mlt raised to power minus 2. You must know your dimension. Or if you don't know it, you just derive it. It's not a big deal. We've seen that before. Good. Viscosity, we've seen viscosity as well. Nice. The viscosity is ml raised to power minus 1, t raised to power minus 1. Good. We've seen that. We've also seen the dimension for velocity. Please let me just make a quick correction. The dimension for viscosity is, sorry, the formula for, or the symbol rather, for viscosity is N. Yes, having made that, let's write on. I have N, so look like N here. The dimension is ml raised to power minus 1, t raised to power minus 1. Let's proceed with that of velocity. So for velocity, you also saw in our previous slides that that of velocity is L t raised to power minus 1. This is very simple. What else are we missing out? Radius. I know we're missing out radius. So radius is a very basic one. So that's L. At this point, let's rewrite our equation as dimension. So we'll start with force. We'll write force as m L t raised to power minus 2. We'll write please look at what I'm getting it from. Write our equation in form of dimension. So we'll write our k. We'll write our r as L. the dimension for R is L raised to power X. Then the dimension for viscosity, that is N. The viscosity now will be in bracket. We'll write down M L raised to power minus 1, T raised to power minus 1. We'll put the power, then we'll put velocity. The next is velocity. So velocity dimension is L, T raised to power minus 1. Then we'll put the power to be Z. So at this point, let's try to simplify. Simplification. So trying to simplify, we see that our issue is in the right-hand side. The left-hand side is simplify. We just have simple things here. Just have M, L, T raised to power minus 2. But here we have L here. We have L here. We have L here. Then here we have T, and also we have T. So with all these things, there is need for simplification. So let's do that. So for L, our simplification will happen like this. We have L raised to power X times, so this L will multiply this L, but this L has to do something. So it has to multiply this first before it will now come and deal with this guy right here. Let's try to do that real quick. This L raised to power minus 1 times Y will result to L raised to power minus Y. So that's what we'll have. L raised to power minus Y. Let's deal with this L now. So L raised to power 1 doesn't have anything times Z is Z. So we're multiplying it with the power. So we'll have times L raised to power Z. So at the end of the day, you will have L. When you multiply all the bases, the laws of indices will tell us that you have X minus Y plus Z. So that's what we'll have based on law of indices. So let's try to do for T. T is here and T is here. So we're going to do T minus 1 times Y. Let's do for T minus Y. That's the first T. We'll do this times this. So we'll do that. We'll have that T raised to power minus Y. So times T raised to power minus 1 times Z. So we'll have T raised to power minus Z. So that at the end of the day, law of indices will apply and will now result to T raised to power minus Y minus Z. Good. So is there any other thing that needs simplification? M is a low, doesn't need simplification. K is dimensionless. At this point, remember, you're not going to be doing anything with this. We're just keeping it aside. We'll just do the first asterisk and second asterisk. So let's write down the simpler form since we've simplified. So I have our simple form to be M L T raised to power minus 2 is equal to K, then L, the simple form which is here, L raised to power X minus Y plus Z. Then where's the next thing to write? Next thing to write is T. T we're simplifying right here. So T is okay. We can also write M. It's fine. Anywhere. Multiplication is doesn't matter the arrangements too, as well as addition. So let's just do minus Y minus Z. Then we're done with T. Then let's just put our M. Now, there is something about this M that I would like to talk about. This M is going to multiply this Y. So we're going to have M raised to power Y. Have M raised to power Y. So that's actually nice. Okay. This is it. So at this point, we'll now equate the powers. So equate the powers. Remember when we equate the powers, we're done. So equate the powers with the powers. So let's do that. It's looking complete text, but still not in this. There's nothing here. The M from the left-hand side is 1. The M, the right-hand side is Y. So you can see, and I told you I like to do those that are stand alone. We're going to do M raised to power 1 is equals to M raised to power Y. So at this point, the base will cancel. We have our y, we cancel out the bases, we have y is equals to 1. That's nice. Let's go with the one that is 2. That is this one. Let's go with this one. So we have t in the left hand side to be raised to power minus 2. I will have t in the right hand side to be raised to power y minus z. We'll cancel the base, cancel out the bases, and we now have minus 2 is equals to minus y minus z. This is nice. At this point, this is my equation 1. So at this point, we're going to substitute y from equation 1 into this equation. So if we replace or substitute the value of y into equation 2, substitute the value of y goes into equation 2, have minus 2 is equal to minus 1 minus z, so that when you take y to the 1 to the other side, it's going to be plus. At the end of the day, you just have z to be 1. I think that's what you have. Don't need to complicate things, right? Finally, we're going to be doing for L because it has 3 variables. I just want to do it last, or 3 exponents. Let's just do it last. L raised to power 1 is equal to 1 raised to power 1. L is equal to raised to power 1. So L raised to power 1 is equals to L raised to power x minus y plus z. Wow, that's nice. We're going to cancel out our bases again, and we now have x minus y plus z is equal to 1. This will be our equation 3. We're going to be replacing the values of y and z into equation 3. So what we're going to now have is that x, we're looking for x, yes, because we have y to be 1, and we have z to be 1. So what will be x right away? If you simplify, you get that x, can't write here, x will be 1, because 1 minus 1, minus 1 plus 1 is 1. So everything is just 1, 1, 1, 1. That's a very nice result, actually. We have x1, y1, and z1. At this point, guys, we're going to put it back to our relationship. Remember, our relationship is at the top. Let's fix our exponents, the values for our exponents, into a relationship, and we'll just be fine. We have our force is now equal to k r raised to power 1 is equals to t raised to power 1 v raised to power 1. There's no points. We're done. So we have r and v, force. This is our relationship between force, radius, viscosity, and velocity. So thank you. The next we'll do now is to give you Bookmaster tips, Bookmaster quiz, so that you're going to try and get your results back to us. Yeah, we've come to the end of this session. For this video, we're going to be dropping an assessment, an assignment. You can try this, and if you would like us to assess what you've done, kindly drop on the comment section done, and we will make sure to give you further instructions and tell you how to go about it in order to optimize the learning process. However, for our students at Bookmaster Academy, most especially the SS1 students, we encourage you to make sure you do these assignments as quick as possible to enable us access and give you the necessary credits where necessary. Also, do not forget to click on the subscribe button and turn on your bell notification so that you'll be aware of our coming videos, which will be uploaded as soon as possible. Thank you very much for sticking around. We really appreciate it.